Good morning, everyone. Thanks for attending today's webinar, Failure of Plastic Plumbing Products. My name is Aaron Plamann. I'm an attorney here at Matthiesen, Wickert Lehrer. I have a mechanical engineering degree that I got from MSOE, Milwaukee School of Engineering, in 2001. And so I assist with a lot of our product liability, subrogation, and defense cases. I've been with the firm for almost 3 years now, and previously I worked for both a plaintiff's firm and in-house insurance defense firm. So I've gotten a little bit of the best of both worlds when it comes to subrogation. This morning I have I'm pleased to welcome Dr. Antoine Rios, a member of the Madison Group here in Madison, Wisconsin. He's been with the Madison Group since 1999 and is a recognized industry leader in the analysis of plastics failures, plumbing product failures, forensics analysis, and plastic parts design. He received a Ph.D. in mechanical engineering, specializing in plastics engineering from the Polymer Engineering Center at the University of Wisconsin-Madison in 1999. And he additionally has an MBA from Edgewood College and is fluent in Spanish. He was born in Venezuela. Currently, he gives multiple presentations on plastics failures, plastics manufacturing, computer-aided engineering. He writes various papers and book chapters, and also is a senior member of the Society of Plastic Engineers, where he serves as director of the Composites Division and the Failure Analysis Special Interest Group. He's also a participating member of ASTM International, that was formerly the American Society for Testing and Materials, and has served as a reviewer of proposals for the National Science Foundation. So he's a great resource, and we're very pleased to have him help us out with this presentation this morning. Before we get started here, I just want to go into a few housekeeping items and let you know how you can participate in today's web event. Right now we're looking at an example of the GoToWebinar attendee interface, which is made up of two parts. The viewer window is where you will see our screen, and hopefully you're looking at this right now. And the viewer window can be resized by clicking and dragging the lower right corner. And then the control panel over here on the right is where you can interact with us during the webinar. So you should see something like this in the upper right-hand corner of your screen. And clicking on that arrow will open and close the control panel. The audio pane provides audio information, and you can use two options. You can join the audio through your telephone or computer. Just select mic and speakers. Click the audio setup to select your computer speaker or headset devices. You can choose to join audio through your telephone. Select Use Telephone, dial the number listed, and enter both the access code and audio PIN when prompted. During the presentation, you have the ability to send questions to our webinar staff through the questions pane. Simply type in your question and click send. We will have a question and answer session at the end of today's webinar, where hopefully Dr. Rios and I can answer a few of your questions. But due to the number of attendees, if we don't get to your question, we will answer all remaining questions individually via email following the webinar. Also, a little over halfway through the webinar, I will have a trivia question for a chance to win one of our 50-state subrogation handbooks, either the ERISA and health subrogation, the automobile subrogation, or insurance coverage books. So stay tuned for that. You can either type in the answer to that trivia question in the questions box, or you can email Jamie Breen directly, and you should all have her contact information. During the presentation, we may ask you to answer a question by raising your hand. This option is located on the Grab tab. And if you prefer to keep your control panel open during the presentation, click View on the top menu and uncheck Auto Hide the control panel. So let's get into today's webinar. We have a couple of objectives. First, we want you, after today's presentation, to be able to identify the different types of plastic plumbing products. And these also include some you may not think of as a plastic failure. Dr. Rios will get into that a little bit later on. We're going to help you able to establish why the failure occurred, so that you may explain that more succinctly to the manufacturer or the adverse adjuster, whomever you're dealing with. And we also want you to be able to protect your claims against manufacturer defenses. And that's particularly helpful in the subrogation realm, where you have to prove your case. So without further ado, I will let Dr. Rios take over and tell you a little bit about the examples of plastic plumbing product failures, and go through some of the rest of the presentation.
Well, thank you, Aaron, for your kind introduction and for giving me the opportunity to present on this plastic failure seminar. Before we go into some of the details of failures of plastics, let's first show some examples of the classic product failures that we see pretty much every day here at our office. So the most common type of failures are the toilet and faucet connector, here on the picture on the left, where they typically fail on the plastic nut at the base of the cup, or the plastic nut. There are a lot of failures related to PVC and CPVC pipes. Typically, they cover fire sprinkler piping, which are typically orange piping, like this picture I'm indicating in the screen. And we see a lot of CPVC failure, typically marked with the flow guard gold symbol. We also see a lot of failures with polyethylene supply lines, like this one. These are typically installed as a supply line, the water supply lines to refrigerators. There are a lot of failures related to what are called PEX or PEX, which basically PEX stands for cross-linked polyethylene. And these are typically used not only to supply water to refrigerators, but also to toilets. We get failures of cracking of the supply lines, or failures due to improper installation on the crimping area. Failures cover also fittings on PVC and CPVC pipes. Fittings in this type of systems are installed using a cement or adhesive, and the typical failures occur due to improper application of the cement, too little cement applied, too much cement applied also is an issue, and sometimes there are problems with the threads. It could be either over-tightening or improperly designed. Failures cover a wide range of water filters, those ones that are installed in line on the refrigerators, water filters that are in the supply line to the home. Shut-off valves, like this one, are pretty common, typically recognized by the quick connect fittings. And those valves that are installed inside dishwasher, washing machines, or refrigerators, these valves are called the inlet valves, and they have a solenoid that turns on and off the flow of water on demand, depending, if you're in your refrigerator and you want you will go to the water dispenser. That's the valve that controls the flow of water to the washing machine, and so on. So failure of that valve will cause water to spray all over that equipment and eventually into the home. Now, there's some less obvious failures. Even though they look like metals, the failure is really of the plastic product. Here on the left, we have the supply lines that are used to some of this type of supply lines used for toilets and faucets. They have a stainless steel braiding. The stainless steel braiding corrodes, but eventually the plastic inner hose burst, causing that water to flow out and failure. We have issues that we see with water heater supply lines. In this case, a stainless steel braided line. It just looks like a complete metal, but it has a plastic rubber hose on the inside that in this picture is covered underneath the braiding, and that rubber hose degrades typically due to the temperature and the chemicals in the water, and eventually allows water to flow out. And then failure of shut-off or angle stop valves. Again, they look all like metal, but a lot of times the failures are on the inside of that valve, where there are O-rings made out of plastic or washers made out of plastic that will cause failure. And just for clarification, those O-rings are, I'm calling them plastic. They're really rubber, but rubbers are a subset of plastics. So that belongs to the plastic family. Okay, now let's talk a little bit about the more specific issues, and these are the aspects that make plastic products unique, especially compared to metal products. Plastics, one of the uniquenesses it affects from temperature, time and creep, degradation, and the high variability failure rates. So let's talk a little bit more about temperature. Of course, this is not unique to plastics. I mean, mostly all products that undergo a temperature increase, or the material that undergoes a temperature increase, is going to suffer on the stiffness and the strength. Basically, the stiffness and the strength of the part is going to decrease as temperature increases. The difference with plastics is that this temperature variation occurs at room temperature and a little bit above room temperature. With metals, you're talking about very, very high temperatures to get a significant effect on the reduction of the stiffness and the strength. But plastics, you know, with room temperature between 70 and 110, 120 degrees Fahrenheit, you can see a substantial reduction in the strength. The picture shown here in this slide shows a PVC fitting that was used in a hot water distribution system. First of all, PVC should never be used in a hot water distribution system. That's stated on the code, but not only because it is in the code, just because PVC temperatures above 130, 140 Fahrenheit will undergo a significant shift in strength. So the strength and the stiffness of material gets reduced, that can lead to deformation and failure. In this example, we can see the thread of the fitting is heavily distorted. This was connected very close to a water heater, and that distortion caused that thread to fail, and eventually the fitting flew out of the connection, causing water damage. Talking about temperature, this is an example of a Saturn automobile that has body panels made out of plastic, and unfortunately was parked near a forest fire and caused those body panels to melt. Of course, this is probably not the fault of the designer. This is, of course, the product was not designed to be exposed to a fire, but it shows you the wide effects of temperature that temperature can have in plastics. A very important aspect, a distinctive aspect of plastic is creep. Creep can be explained as the deformation of the material when it is exposed to a load over a period of time. And the key here is period of time. This type of damage occurs over long periods of time, won't occur short time. So an example that we show here, we see a coat hanger. Probably most of you have seen this effect in your own house, where at time zero, when you buy the hanger and you hang, let's say, a heavy pair of pants, the hanger is going to be completely straight. But now, over a period of time, that those pants hanging there will deform the plastic. This picture shows the deformation after 1 year, but actually if you leave those pants there over a long, long period of time, could be 5, 10 years, that hanger may actually crack. And that's really all caused by creep. Obviously, when we look at plastic products, mainly, just for an example, talking about coupling nuts and supply lines that fail due to creep, you don't see so much deformation. The deformation occurs more on the microscopic level and then eventually leads to failure. But it's a very, very important aspect, the distinctive aspect of plastics. Another issue is that plastic materials have a large variability in their mechanical and material properties. Unlike metals, in metals, when you talk about grade of metal, they're heavily standardized, all the ingredients that go into that grade. But with plastics, there's no such standard that cover the exact ingredients that have to be used. So mainly plastics are specified due to their mechanical properties. But plastics are made of many ingredients, and as these ingredients are mixed and put together into the equipment that manufactures the raw material, there's going to be large variability on the recipe, if you want to call it that way. And this is going to cause a large variability on the properties. Therefore, we have to be conscious when we, or aware when we hear the typical argument from the manufacturer that says that the product was not effective because the failure rate is very small. And I'm just going to paraphrase what says in the box, but this is very important. A defective product does not always result on failure of all parts. Not all parts are manufactured the same and are not subject to the same environment. What I want to say with this statement is that even if you get a failure, maybe 1 out of 1,000, that still is a failure. And is a lot of times a design failure because the designer should account with the variability in the plastic. That variability is a fact of life, and they had to design their product to withstand the variability. So the safety factor that is added to the design should account for that variability. Therefore, just because a failure occurs 1 in 1,000 doesn't mean that it's not a design failure. And you probably heard the argument of, oh, we make millions of this part, and we only see very few failures. So be aware of the fact that that's necessarily not a good excuse.
Dr. Rios, I will interject that that is a very common defense argument that is made, and I think everyone needs to be aware that there are counter arguments, to make on that. And so don't just take it at face value that the manufacturer or the insurance, the liability insurance adjuster is stating that we make millions of these parts. Your one failure, shouldn't count, and it does. And there are arguments that you and your expert can make, to counter that.
Very good point. Excellent. Moving on. Okay. Chemical exposures, plastics, and this also happens in metals. When we talked about rust or corrosion, that's really a type of chemical degradation of the metal, but it with plastics occurs when they are exposed to temperature and chemicals. And when we say chemicals, let's not think about chemicals like a foreign substance or something that should not be in contact with the plastic. Like in the picture here on the left, this is a supply line to a refrigerator. And this degradation is occurring due to two factors, high temperature, but also due to the chemicals in the water. But in this case, it's just the chlorine in the water, which is an expected chemical. Potable water is potable water will carry chlorine, and that's known to affect some plastics if they're not properly designed or manufactured. So when you combine the high temperature of the supply line, let's say running near the compressor of the refrigerator, which is also an expected environment, plus the chemical in the water, it will cause degradation and eventually failure. The example in the middle is a fill valve. This is the valve that's inside the toilet, and controls the flow of water. These valves typically degrade due to the exposure of chlorine. Sometimes it's just the chlorine in the water. Sometimes it's chlorine added from cleaners used to maintain the water in the toilet tank, disinfect or clean. Another typical example of degradation is this shut-off valve that is used, or drain valve that is used on water heater. This is the valve that is located at the bottom of the water heater and allows you to drain the water. And this degrades due to temperature and the expected chlorine in the water. Now, after looking at these aspects of plastic failure, let's look at some of the primary causes. Design. Design is a pretty common issue with plastics. If they're not properly designed, it's going to lead or facilitate failure. Let's take as an example one of these coupling nuts that are connected to the toilet, the supply line to the toilet. This is the plastic coupling nut. If we cut this plastic nut and we look at the threads, we can see here something similar to what is seen on the picture on the right. We have thread that has what we call geometric transitions. Here where my pointer is, that's a geometric transition. And what happens is that at a geometric transition, the stress or the load feel by the material is increased. This is what we call a stress riser or a stress concentration. So in that area of the thread, we had a stress concentration. That's actually known, and it's a fact that the stress is going to increase there. Therefore, it should be designed to withstand the incremental stress due to the change in geometry. In this case, it's a rounded thread. The thread obviously is required to have the shape so it can mate to the valve, but nevertheless, we'll have that transition that increments the stress. But the problem with this coupling nut is that the termination, what we call the termination, or the thread at the bottom where it meets the flange, is much sharper. You can see that this thread, the corner here, is a lot sharper than this one. So this is more rounded, this is more acute. So that actually is going to further increase the stresses. So the stress concentration is going to be much higher as the sharper the the corner is. And as you can expect, that's where the failure is going to occur. It's going to initiate at that sharp corner, and it's going to progress outwards until it covers the thickness of the part. Therefore, in this case, this is a design defect. They left this corner too sharp. They should have rounded it. And it's very, very significant, the reduction of stress that can be attained by just rounding the corner. And it's something that is very easily done at the manufacturing level. And because it was not done, creates a sharp corner and failure. Other types of failures that we see is material issues. It could occur with the same material. As I explained earlier, there are going to be differences from batch to batch of the same material due to the polymerization, which is the manufacturing of the raw material, or the mixing of the different additives and fillers. Plastics are not just a plastic per se. They are made out of different additives and fillers that if they're not properly mixed, it's going to create issues. Material substitutions are also a problem. Sometimes the manufacturer replaces the material A by material B because it is similar, in quotes, but at the end of the day, yes, it is similar in some properties, but maybe it has the same strength, but maybe it doesn't have the same creep resistance. And now the product, instead of failing after 10 years, it will fail after 5 years. So these are issues that we see on a daily basis. Problems caused by manufacturing defects. Basically, you're changing the plastics from being a good material to a bad material, either due to degradation. Thermal and moisture are the most common, where the material is manufactured at very high temperatures, or if it's not properly dried, the moisture is going to cause degradation of material, which eventually is going to cause degradation of properties and probably failure. And issues due to machine settings, creating voids, ripples, mixing issues, or weld lines. Just to explain weld lines, because this is a pretty common issue with plastics, let's look at this picture in the slide. In this case, material is flowing from the bottom of the screen to the top. The material flows in this manner inside the mold so it can shape to the final geometry that you want. So as the material flows around openings or holes that are purposely made in the part, when the flow front divides around, that flows around the holes, divides and meets in the opposite end, at that union you're going to have a weaker area, which is called the weld line. And this is a fairly common cause of failure. We also have problems with user abuse, and a lot of times this abuse is due to improper installation. The picture on the right shows a PVC pipe, the fracture due to thermal expansion. So if the pipe is not allowed room to expand, eventually it's going to crack. And this happens typically when you have very long runs of straight piping. You need to allow for that expansion. The picture on the left shows a water filter has fallen into the ground and failed. Now, expected life, this is a very common question that I get on a weekly basis. People ask me, Dr. Rios, how long is this supply line supposed to last? The answer is not simple. There is not a straight answer to the expected life of a plastic product. Unfortunately, there are not standards out there that explain how long they should last, with the big exceptions of piping. Plastic piping is, for that, is very well established. So how can I answer that question? Well, if you ask that question to 5 different experts, I'm sure you're going to receive 5 different answers. But the bottom line is that the manufacturer should consider the life expectancy during the design stage. It should be one of the first parameters when you design a plastic product. How long should it stay? How long should it last? And the expectations, from the users are going to vary widely. So it is the job of the manufacturer to explain to the user how long this product should last. It's the job to convey that information. And the way it most, sure.
Oh, go ahead.
The easiest way to convey this information from the manufacturer to the user is by the use of labels or manuals that tells the user how often they have to replace the product. However, here I have two examples of problematic labels. The one on the left tells you to replace the filter every 3 months. Okay, that's not bad, but in the bottom it says based on frequency of use and local water conditions. Well, that in itself implies that this is related to the quality of the water. So if you want to filtrate your water better or worse, not necessarily. It says there that it's due to problems with the structural integrity of the filter. Another issue that we see commonly with fill valves in toilets is that the seal inside the valve will fail. Well, if we look at the instructions, it says if fill valve won't turn off, now let's jump to point number 2, the seal inside the valve tub may be damaged. Replace the seal. Well, that's not helpful there. It's telling you to replace the seal after it fails. This is not a maintenance issue. This is telling you to replace it after it fails. It should say, well, replace every 2 years or every 5 years. So the manufacturer shouldn't have too much of an argument saying that it was not properly maintained or replaced. Looking at labels that are more effective, in this case, this label explicitly says that the filter should be replaced every 5 years, and units that are opaque should be replaced every 10 years. So then, in this case, expectations are set and clearly stated when it should be replaced. Aaron, I think you have something to add probably to the labels, right?
Yeah, the life expectancy question is something that comes up not only with plastic plumbing products, but also with just about every kind of a products liability situation. And there aren't any really good, charts that people can use. As Dr. Rios mentioned, if you talk to 5 different experts, they'll probably give you 5 different ranges on, just for instance, how long a supply line should last. There are some governmental standards. Sometimes you can find a state, building manual that can, or administrative code that can set out, especially with senior housing and other types of housing that are fairly well regulated. Sometimes you can find some life expectancy codes, but if you talk to different experts, different insurance adjusters, that life expectancy really varies. And from a legal standpoint, that allows you to make some arguments, especially if you have an older plumbing product. Just be careful that the state that you're dealing with doesn't have a statute of repose that would bar your case. Some have products liability statute of reposes that that will bar your case after, let's say, 10 years after the date of manufacture or the date that the part is placed into the stream of commerce. And also, probably, if it's an older part, don't have any kind of a warranty claim to make. But if you are within either the part's written label as far as a warranty, or if you have some sort of expectations on the label, then that is best to go off of. If you're just dealing with an older part where you don't have anything that lays out the expected life, then there are some gray areas that can be argued.
Thank you, Aaron. So let's look at, of course, we cannot cover all the arguments that you probably hear from manufacturers. We probably will spend here hours talking about each one. But we hear arguments such as the part was in a good working condition when it left our facility. so then the failure must have been from a user abuse. We hear that a lot. And just by having listened to what I explained a couple slides ago, you can tell that this is not a good argument. There is such a thing as degradation of the plastic over a period of time and creep. So yeah, the part left in a good condition, but it failed over time. So that should be designed on the part, and it was not appropriate design. So this is not a valid argument. Our part meets and exceeds all the applicable standards.
I checked the battery.
This is not a real argument because a lot of standards do not necessarily sorry about that. So because they make that argument, we have to be careful because some standards do not necessarily specify how the part can be designed. It doesn't specify all the details. The standard just is a starting point for the manufacturer. Then the manufacturer's duty is to take the standard and make the changes required for that plastic product. The standard may cover also metal products and plastic products. So we have to be very careful. We have to understand which standard they meet before we accept this as a valid argument.
Dr. Rios, if I may also, especially with plastic parts, the issue of creep needs to be explained to a lot of liability adjusters and also defense attorneys if the manufacturer gets a defense counsel involved right away. They will have the argument that, well, this part was able to stand up for 5 or 10 years, and that's not always a great argument just due to the creep. A plastics part is going to fail over time, whereas another type of part made from metal or ceramic, may fail sooner. The plastic is going to kind of hold on, and it will fail over time. And so a lot of times I have to explain, how creep works and what even it is to both liability adjusters and defense attorneys. So that's always something that needs to be explained.
Thank you. So moving on, what happens when the plastic product fails? How do you figure out what's going on? You can, send it to a program, a TV show like CSI that may give you an answer very quickly, or you can send it to an expert. In our case, what we'll do is different testings. And I don't have the time to go in details about each of these tests. But we have two groups of tests, non-destructive and destructive. Obviously, non-destructive is the preferred type of testing done at least at the first level. And every failure that we looked at first undergoes a visual examination and an optical microscopy. And the reason we do this is because that gives us a very good idea of where that fracture initiates, how does that fracture progress through the thickness of the part. The speed at which the fracture progresses gives us a very good idea of what type of load it was applied or what type of failure we're talking about. If it's a creep failure, we can distinguish. There's certain specific features that we can recognize in the fracture under the microscope that will tell us this is a creep failure that occurred over a period of time, or maybe it was a very quick failure that it just may have taken just a split second, something like a freeze type of failure or impact or a drop or somebody hitting a part with a hammer. We can distinguish those by looking at the fracture surfaces. We can also distinguish if there's degradation of the plastic a lot of times with just the optical microscopy. Sometimes more testing has to be done, like CT imaging and X-rays that would give us a very good idea on the inside of the part without having to cut it open. Experimental type of analysis where we replicate failures with exemplars. This is very useful. If we can replicate a failure with an exemplar, well, maybe we can create a good theory of causation theory. Destructive testing includes scanning electron microscopy. Sometimes this can be done non-destructively, but I like to put it under destructive because that's more likely than not that will require destructive testing. This is a more sophisticated microscope where high magnification and high resolution fractography can be performed. When I refer to fractography, it's basically the study of the fracture surfaces. And then tests like EDS and FTIR, which give us an idea of the composition of the material, helps identify the type of polymer, and if there are any foreign substance that should not be there and are causing degradation. We typically can identify with this test. If we can, then there are some more complicated or complex tests, but also more expensive that can be performed, and they're going to go through those now. But at least this covers the most common tests that we typically perform in this plumbing products. So, Aaron, with that, I give you the stage or the screen.
Sounds good. Thanks for all of that information. I'm going to take over and talk a little. Oh, hello, everybody. I am not sure why we lost the audio, but I believe we are back. Let's do this. Let's make it back. And I think from the questions segment, I thank everybody for chiming in. Our phone system dropped now, so sorry about that. But I'll try to pick up where we left off on this. Just from the initial scene documentation, especially, and I was talking about a toilet supply line. Not only getting the the supply line itself, but how it was installed, some of the general background pictures. If you have a plastic part that is connected to other parts, it's nice to have the everything that was connected to it and around it. With a supply line, let's say in a faucet, a lot of times you probably have heard the defense that it was some sort of a chemical degradation of the metal. It'd be nice to see what was in that cabinet. Were there cleaning materials? Was just paper towels stored underneath there? So the more pictures, the better. And getting all of the surrounding evidence is important. You want to protect the failure region, and I think this is fairly repetitive for most everybody here that deals with subrogation. But my final point in this is just kind of the considerations in the evidence transfer, both to the expert and to the potential defendant. A lot of these small plumbing products, can be easily be shipped, but you want to take into consideration, the size of the loss and how you can protect yourself should that product be lost or misplaced, so that you don't get any sort of a spoliation argument. Next, one of the biggest things we're running into now, especially with foreign manufacturers, are the identification of the manufacturer. And of course, it's easiest if the label for the plumbing product is still intact and attached and given to you with the product. However, if not, exemplars may be used. And then also with the identification of different manufacturers, especially foreign ones, different databases may be used, such as the IAPMO certificates. Many of you have seen the UPC label stamped on a part, and that'll usually also have a 2 or 3 letter code. And IAPMO states that each product that is certified by it must be identified in some manner so that somebody can tell who the manufacturer is and then also where it is manufactured. From a causation standpoint, this is where you want to get Dr. Rios or someone like him involved, just having an expert opinion on causation. Was it a design defect, manufacturing defect, failure to warn? You need that expert opinion to make your case, and Dr. Rios can certainly help out with that. After his investigation, he's going to come up with a statement of what actually caused the failure, and then of course that plumbing product failure must be the cause and fact of your damages. That's fairly rote information. But make sure that you have your expert opinion on causation. Don't just have your expert state that it's a manufacturing defect. Have them state why. Why would it be considered a manufacturing defect? Why would it be considered a design defect? And be careful that if you're in a state where you need an alternative design, that your expert can identify one and can, potentially, if he has to testify, that that there was one out there that could have been used by the manufacturer as an alternative. And I just want to, since we're running a little short on time, I'll just kind of talk briefly on the next couple of slides. Just your subrogation demand, I like to put a little more information in there just with regards to your investigation, your identification of the manufacturer. What does your expert say is the cause of the failure? What is your legal standard for your jurisdiction? Do you need to prove something? Do you not need to prove something? Do you not need to show that an alternative design is necessary? Just that the threads of the coupling nut, the design of those, were defective. and then all of your damage support documentation that you need to make your claim. Oftentimes, if you just see a demand letter that just basically states that your product has been determined to be the cause of the failure, our damages are X number of dollars. Please send your payment to X, Y, and Z. A lot of times, that's not going to be an effective demand, and it's not going to allow them to give you a meaningful response. And then finally, I just wanted to finish up with the foreign manufacturers. We're in a global age these days, and a lot of plumbing products and plastics products are coming from overseas. And you probably all have heard the generalization of bringing a lawsuit or trying to pursue a Chinese or Taiwanese manufacturer, or anybody actually in Asia. There, Singapore, Malaysia, Vietnam. A lot of them have manufacturing plants, and a lot of importers are constantly switching manufacturing plants, basically keeping up a shell game of where it was manufactured and who manufactured it. So just be aware that when you're in the United States, you'll have some legal issues to consider, including jurisdiction. If the foreign company has no ties to the U.S. and will not, be tied in or have any sort of assets in which to pursue, you will have some difficulty with collecting, any sort of a default judgment. A lot of times, the Chinese and Taiwanese court systems will not recognize a default judgment from the U.S. just because there wasn't a legal adjudication on the merits, which is necessary a lot of times in foreign courts. And I just realized that we kind of skipped over with some of the technical issues here in the middle about the trivia question. So let me read this off and have you guys respond, and then Dr. Rios and I can answer a few of the questions that have come in, and then we can give the answer and give away the book and wrap up the program for today. So the trivia question is, what is the average cost of a water loss claim due to a materials failure? And this is in U.S. dollars, and I'll let you either type it into the questions sidebar of your webinar, or you can email Jamie directly, and we'll announce the winner here after Dr. Rios and I answer a few questions. Dr. Rios, one of the questions that has come in is how do you identify a plumbing product such as a supply line without a label? How do you kind of go through and definitively state, what the product is and who manufactured it?
Great question. I will say that we probably can identify about maybe 90%, 95% of the products that we receive, and obviously the easiest way to identify is to looking at labels or markings that are unique to certain manufacturers, that we can see them stamped on the parts. That's the easiest way to identify them. However, when we don't have labels or any markings, or sometimes the markings are pretty coded. Basically, you have an A and a B. Okay, what does that stand for? What we do, based on our experience and the large exemplar database that we have, we eventually end up comparing the evidence to our exemplars until we find a match, and then we can say that with most likelihood, due to the exemplar comparison, that's the manufacturer of that part.
And I will kind of add to that, if you are using an exemplar match to basically prove that the part was manufactured by a certain company, the more information on the exemplar and how it matches, the better. And maybe also even some information on how that exemplar is different from other let's say, supply lines. How the connecting nut is, differently, designed or produced. And so, the more information on that type of thing, the better when you are looking at this type of exemplar match. And Dr. Rios, also, let me kind of go back to one of your slides when we started talking about life expectancy. And you mentioned that one of the exceptions you had are the PVC piping. Where are those guidelines found, and why are those the exception on the life expectancy side of things?
Yes, and I want to be careful when I say exception and how is that understood. Obviously, that's depending the material of the pipe. For PVC and CPVC and polyethylene, there are ASTM standards, and they vary depending on the type of pipe. Even PVCs have different types of standards that they abide for, but most of those standards call or establish a testing where the pipes should withstand continuous pressure over a period of 50 years. So that's the test that a part has to withstand. It's a test of 50 years. Doesn't literally tells you, okay, the pipe should last 50 years, but the testing that the pipes should be subject to has a time of 50 years.
Okay. Well, I think we're almost to the end of our time this morning. I know a lot of you have duties that you need to get back to. I thank you for attending this morning's webinar. But let me give you the answer to the trivia question. And the average cost of a water loss just due to a materials failure is $4,296. And while it doesn't sound like a lot, this materials failure is the most common type of plastics or plumbing products failures that leads to a water loss. This is from the Institute for Business and Home Safety, a study they did back in 2013. And they found that 2 out of every 3 claims, the other claims were either made through installation error or frozen piping. And I know that a lot of you have handled losses that are much, much greater than that. And especially when you get into a situation where a supply line or something else fails up on the 2nd or 3rd floor of a house, where you have water that wants to find level and will oftentimes trickle down throughout. So our winner this morning is William McClure, and Jamie will get in touch with you to get the information from you for the shipping of the book. And again, I'd like to thank you, and also Dr. Rios, I really would like to thank you for taking your time this morning and helping us out and talking about some of these plastic plumbing product failures. If we have some questions that we weren't able to get to, either myself or Dr. Rios will email you directly with some answers and some of our thoughts. And always, if there is anything that you think of after the presentation is over with, both my email address and Dr. Rios' address is up on the screen. So with that, I hope everyone has a happy holiday season. Dr. Rios, thank you so much for your time this morning.
Thank you very much, Aaron, and thank you for listening.